Welcome to the 9th in the series of videos on current electricity. In this video we're going to do some problems to find net resistance. So let's look at a problem which is combining what we have studied so far. Let's say this is a combination, and you have here is 2 ohm and this is 6 ohm and 3 ohm. So whenever you get a problem of this kind, the first thing you do is to label your resistance. So you have R1, R2, R3. And we know that how to resolve the parallel resistors. So we know that, hey, 1 by R23 is 1 by R2 plus 1 by R3, since their resistance is in parallel. So that's 1 by 6 plus 1 by 3. That's 3 by 18. Oh, sorry, is it 3 by 18? Yeah, 3 by 18, or 1 by 6. Or you have R23 equal to 6 ohms. You have so now you have a circuit like this. R1 and R23, this is 6 ohms and this is 2 ohms. Now your R net for this would be 2 plus 6 because they are in series, and that's equal to 8 ohm. So that's how you can resolve this. Now it's you can do a shortcut when you have parallel resistors, and the shortcut is before you substitute this, you can try to find out what would in general two resistors in parallel give you. So if you have 1 by R is 1 by R1 plus 1 by R2, you have this as R1 plus R2 by R1 R2, or in other words, you take reciprocal, R is R1 R2 by R1 plus R2. So in this particular case, we have R1, let's look at this separately. So because R1 and R2 are confusing, so let's say this is 2 ohm, which is R1, and you have here 8 ohms, which is R2. So your net resistance would be R is R1 R2 by R1 plus R2. That is 2 into 8 divided by 2 plus 8. That would amount to 1.6 ohms. So that's how you can easily find the net resistance. Let's do one more problem. So sometimes you may get a little convoluted diagrams like this, like a star or something like that. And you have here, so you have 3 ohms. Here you have 3 ohms and 2 ohms. And here you have 6 ohms and 4 ohms. And you have to find the resistance between A and B. I urge you to pause the video and try it yourself. Just give you a hint. Whenever you get a wire like this, you can actually flatten this a little bit. So it's up to you how you put it. So you can say, hey, this is 3 ohm and 2 ohm. This is connected to a 3 ohm in parallel, and this is again connected to a 6 ohm and 4 ohm in parallel, and there you have your A and B. So this is your equivalent circuit. I urge you to pause the video and try to solve this combination of resistance. The first thing you got to do is you have to label these resistors. Once you have labeled these resistors, then you can go step by step. We can say R12 would be 3 plus 2, which is 5 ohms because they are in series. In parallel would be, and then you can reconstruct things in parallel, which is, this is R3. And here as well, you can combine the resistance of R4 and R5, which will add up to 10 ohms. So you say R4 5 equal to 4 plus 6, 10 ohms. And then you have A and B on both these sides. A, B. We can write your resistance as 1 by R is 1 by R12 plus 1 by R3 plus 1 by R4 5, and that's equal to 1 by 5 plus 1 by 3 plus 1 by 10. Taking the LCM, 30, 6 plus 10 plus 3, or in other words, this is 19 by 30. So your R would be equal to 30 by 19 ohms. Let's do one last problem. This is the third one. So you have a 6 ohm, and let's say you have a 3 ohm, and you have here 2 ohms. So find the net resistance between A and B. Pause the video here and try it yourself. So first you label your resistance, and here we will try to use a shortcut. You have R1 and 2 in parallel, so that's R1 into R2 by R1 plus R2, that is 6 into 3 by 6 plus 3, 18 by 9, that's 2 ohms. So your R1, 2, 3 would be equal to 2. So this has resolved to 2 ohms. So now adding this and this, your R1, 2, 3 would be 2 ohm plus 2 ohm, that's equal to 4 ohms. So that's how you do these problems. I hope these were a good set of questions that you can build upon in your further practice exercise. So see you until the next video. Bye.